A geometric sequence has first term 2 and common ratio -3. Which term has the value -4,374? So the key word we see here is a geometric sequence. The formula to memorize is u to the n is equals to u1 r to the n minus 1. The first term is given as 2, so we know that u1 is equals to 2. The common ratio is -3. That's r. So the question is, which term value is -4,374? We'll plug in the value, this over here. So this is a 2, -3, n minus 1. So now the rest is algebra. Let's divide both sides by 2. So when you divide it, we get -2187. And because we know that n, which is the term number, is a natural number, we know that n should be a nice number that's not a decimal. We could, by trial and error, quickly realize that -3 to the 7 is equals to this number here, -2,187. So by trial and error, if you're too low, if you try -3 to the 6 and it's too low, and if you try -3 to the 8 and it's too big and it's not matching this number here, just keep trying with your calculator until you match the number. And by doing this, we can now equate the exponents. 7 plus 1 is 8. So when we say n equals 8, which term has the value? It's the 8th term. So now that we know the answer is the 8th term, n is 8, let's take a moment and analyze this part over here. So when n is 8, we have 8 minus 1, which is 7, -3 to the 7, which is an odd number. Notice how the odd exponent allows this negative base to end up to be overall negative. Negative times negative times negative times negative, etc. An odd number of times is negative. So the only way this would work is if this was n indeed is even, because an even minus 1 becomes odd. Now another way of solving for n, besides guessing and checking, would be to log both sides. But by logging the left side, which would be log of a -2,187, we would have an error because the domain of logarithms, it must be greater than 0. So in order for us to have an actual answer for n, we know that we're going to be canceling out the negatives on both sides of the equation. So let's look at the answer again. We know the answer is 8. 8 minus 1 is 7. -3 to the 7 is the same thing. I'm just going to focus on this blue part here. I'm just going to work on the right hand side. Let me just copy down the left hand side here. Is the same thing as -3 to the n minus 1. As you can see, when n is 8, we have 3 to the 8 minus 1, which is 3 to the 7. And 3 to the 7 is a big number. It happens to be 2,187. But when we stick the negative sign here, the statement here is equivalent to the statement over here. I'm going to divide both sides by -1, and so we get 2187 is equals to 3 to the n minus 1. And now we can log both sides. We log both sides, we have 2187 is equals to log of 3 to the n minus 1. Log rules states that we can drop the exponents. We have n minus 1 log 3 is equals to log 2187. Divide both sides by log 3. We have n minus 1 is this business here. And finally we have n. We add 1 to both sides. We get 1 plus log 2187 divided by log 3, which is 8. But even though you didn't have a calculator, we'd be able to do this. So we know that according to log rules, we can even change the base. I'm going to change the base to base 3. And I'm just going to continue my work up here. So we have n is equals to 1 plus. Gonna think here, 3 to the what is 2187. 3 to the, we just did it over here, it's 7. So this part here, 3 to the what is 2187, it's going to be 7. And the bottom here, 3 to the what is 3. Whenever we have a log of the same, it's going to be 1. So 1 plus 7 over 1 is the same thing as 1 plus 7, which is 8. So in this case, guessing and checking the original green way is faster. However, if you have a calculator and you know how to log both sides, you can just crunch it on your calculator pretty fast as well. And please note that you may also be able to use your graphing calculator to list the terms of the sequence